recommend using your fingers on these at all, even though you have your gloves on. Cotton forceps to put a little bend on the end of that. Even though it might make it dull, some people say, well, you're dulling the file, no, this is okay, this is just for Pathfinder, it's okay. It's okay, we got a Pathfinder bend. If I had a cotton forceps here, I'd show you how to do that. Cotton forceps.
Grab it.
So the bend only needs to be in the apical, say 1 millimeter or maybe 1.5 or 2 millimeters. The rest of the file follows. It's all connected. It's one piece of metal. So if you can get this tip to go around the corner or past any ledge, then there's no problem. So I'm just sort of like a bow on a package, you know how you make it round? So now I have what, you know, if you can see that, it's a rounded bend in the apical 1 or 2 millimeters. That's a perfect and a good Pathfinder bend. And the other thing to do is always use your RC prep, which is where the blue.
There's somewhere here.
Oh, here it is. I don't know where it went. Yeah, here it is. So always, the RC prep should be, I don't know if the camera can see this, yeah, should be right in here. We've opened it up already. You put this on the file, and you tuck this in here so it's nice and clean and neat, and then all your files are here, and you can just pick them up right before you use them, put them in here, dip, okay, and then you've got RC prep on there, you've lubricated, and you just tip it in there, and you wiggle like this back and forth until you get it down to length, and then you make sure it's loose, file in and out, in and out, in and out, without any rotation, because these are stainless steel files, and then you move on to the number 10, I think it says, right? Doesn't it say that?
Yes.
Yeah, go ahead and read that now. 15.
After you create the number 8 stainless steel file and number 10 stainless steel file to the tentative working length with the 1 mm more, you create a Pathfinder bend on the files. Then you lubricate the file with the RC prep. Then you insert number 8 file into the sodium hypochlorite filled or water canals. Then you use the light apical pressure with the watchwinder motion.
Yep.
Then you establish the tentative working length with the 1 mm more.
Yep.
Then you use coronal apical motion, that is filing, until loose.
Filing.
Then you again repeat with number 10 file at tentative working length with 1 mm more.
Okay, so these are, notice these are all at tentative working length plus 1 millimeter, which is a little bit long maybe. Okay, then after that, so we've done that, we're up to a number 10 now, okay?
Then you irrigate, use 12 cc syringe, 27 gauge needle with 1:4 sodium hypochlorite or water irrigant. Substitute 100% water. Then you insert needle tip until it bends.
So I'm doing that now, yeah.
So doctor, I have a question.
Then back off slightly.
Why do we add a millimeter to the Pathfinder?
So we want to have what we call patency length, which is going to be working length plus 1 with the small files, 8 and 10. But we notice at the 15 we go back. So we want to, during the whole canal instrumentation process, we want to keep the apex open with the number 10 file.
Oh, so you want to keep beyond the apex?
Right.
Go beyond the apex.
Working length plus 1 millimeter.
Mm-hmm.
Right.
Because when we prepare prepare the canal, we go actually millimeter less, right?
Right,
we don't actually go beyond the apex.
That's correct. So when you set all the other files here, you'll be going to working length, but only the size 8 and 10 are called patency length, which is working length plus 1 millimeter. So we want to, right from the beginning, see if we can have patency with a number 10 and maintain that, but not more than that. That would be ripping open the apex. It's really meant to just pass through the apex passively without really enlarging the dentin at all, because there's a natural opening there, and we want to keep that natural opening open with a number 10 file.
Is it also called recapitulation?
So no, not exactly. Recapitulation is going a little bit farther than
Farther.
yeah, that's right.
Okay.
Yeah.
Should I read
Keep
the next?
going, I think, yeah.
Insert the needle tip until it bends, then back off slightly. Flush the canals with several cc of irrigant. Suction with small tip on high volume evacuator.
Okay, so we did that. We just irrigated. Now, go ahead.
Set number 15 night dye hand file to tentative working length. Number 15 is the smallest consistency. Readable file for working length x-rays. Do not use number 8 or number 10 files for x-rays.
So that's correct. So we don't want to see you taking x-rays even if you can do it. With a size 10 or size 8, it doesn't show up very much. So this is, we're gonna finally make an X-ray now. This is set at our tentative working length, and we'll have it in there now. And we got there by using 8 and 10 first, and then 15. Now we just do what it says.
Then lubricate. Set number 15 hand file to tentative working length. Number 15 file is the smallest readable file for working length X-ray. As I said before, do not use number 8 and number 10 files for X-ray. Then lubricate with the RC prep. Use light apical pressure with the watch winder motion. Establish.
Yeah, I just did it. So I'm using the RC prep now. Got the number 15. I wiggle it in there with a light apical pressure and this watch winder motion back and forth until it goes down to the right length. I don't know what that is. Okay, now, okay, that's it. It was simulated. Okay.
Establish the tentative working length. Number 15 file fits loosely in a wide canal at tentative working length. Use larger files until a file fits firmly at tentative working length for working measurement film. Firm pressure minimize unintended file movement during the X-ray procedure. Take the radiograph, wire measurement image.
Okay, so what that said is this is the minimum size, but many of your canals will be very large. They'll be already a number 40 or something. So then you shouldn't go to a larger size. You should just use the size 10 or better, 15 or 20. 15 or 20 or 25 maybe. But if you put a 40, people criticize that. They say you're going to push the pulp tissue out the apex. So then you just take a loose file, number 25 or 30, and pack some cotton or a piece of this sponge. You can rip off a piece of this sponge and just put it in next to the file to hold it in position. In other words, to wedge it in position with a little piece of sponge at the correct length. And then you'll take an X-ray of that, even though it's a little loose. Got it?
Until there is the exam, right?
Till there's what?
Like until this step is the exam next week.
Performance exam.
Yes, even through this, all the way through. We're not into guide path yet. Correct, that's
Yes,
right. This
yes.
will be exam. Yes, you'll be doing this next week, along access and all these steps, yes.
Okay.
Next.
Remove the file, remeasure file length.
Okay, the reason we do that is the file, this rubber stopper gets bumped sometimes, and you put it in at 18 millimeters, and then you take an X-ray and say, okay, that's at 18 millimeters. But if you check it again, you have to confirm that it really was 18 millimeters and it didn't slip, because sometimes it does slip. And you thought it was at 18, the X-ray was really taken at 19 millimeters. So you've got to put it in at a certain length, and then you have to confirm that the X-ray was taken at that length by removing it and measuring it again. And if it's off, it's different, then you have to ask yourself, did I take the X-ray when it was at 18 or 19? And you say, I'm not sure. You start over again, right? These have to be certain what length that file was, because we base everything on that. So it's really critical to make sure you have the correct length.
Remove the file, remeasure file length, then record the working measure length.
Right. So here it is. You can just record it in here today if you want to. Record the working length. So you're recording the wire measurement. Now this is different. This is what the length is of the file in the tooth. So you measure that length, 18 millimeters, and you insert it at that far. So it should be 18. So your wire measurement length that you took the film with was 18. Okay.
Working length is derived from the wire measurement film. Occasionally, working length is equal to wire measurement if no length adjustment is needed.
So you got that? So the working length should be, the file tip should be 1 millimeter exactly from the tip of the apex as seen on the X-ray. So in that case, then in that particular case, the wire measurement equals the working length, no change is necessary. But sometimes you have to add a little bit, sometimes you have to subtract a little bit, and you have to make that calculation on the computer. Okay?
Can you just tell them to use this? Because this formula is going to be on the exam.
Yeah, this is the exact formula, if you can see this on the film there. So you're gonna just have to say, you don't even have to tell us what length. You don't have to tell us that it was at 18 millimeters. We're just gonna look at the X-ray and say, this is 2 millimeters from the apex. They needed to circle plus 1, right? If it was 2 millimeters from the apex, and ideally you're supposed to be 1 millimeter from the apex, so you're supposed to make the change plus 1 millimeter. Or 0, no change, like when it's perfect, or minus 1. So we're going to give you this formula. It says the working length is whatever your wire measurement is, and we're not going to try to figure out that whatever it is, you're going to show us an X-ray. That X-ray, you're going to put it in your thing, And we're gonna look at that x-ray quickly on, it'll be printed out, and we'll say, this needed to go 1 more millimeter because it's 2 millimeters away. And then, so we'll look at your sheet, and we'll say, you should have circled +1, and if you did, excellent. And if you didn't, you know, it's not right. Got it? Yeah, okay.
Note the file tip position on film relative to apex and adjust plus or minus from wire measurement to working length. For example, working length is equal to wire measurement plus 1.5 mm, or working length is equal to wire measurement minus 0.5 mm.
Correct, there's an exact example of how it should be written out right in here, and you want to follow that example that's right in this little manual. Correct.
Record working length derived from wire measurement films.
Right, so you have to, the working length is an important number. Everything, all your other files from now on will be set at working length. You need to have the working length. So that's good. So that's the big part of this exam, and the big thing you'll do today is figure out the working length of each of these teeth. And you have to keep this for your records, because we're going to go back to these teeth again later in about 3 or 4 weeks and instrument these. And if you didn't write it down somewhere, you're going to have to do it over again. Refigure the working length. Okay? Stop.
It's not on. No, it's on.
Just stop.
It's there. It's dead.